Have you ever looked up at the night sky and felt a sense of wonder? Have you ever felt small beneath that vast, dark blanket sprinkled with countless points of light? It's a feeling we all share, a deep, primal curiosity about our place in the cosmos. We see the moon, a familiar companion, and a few bright planets tracing their paths. But what lies beyond our sight, beyond what our telescopes can reveal? The universe is far grander, far stranger, and far more magnificent than most of us can possibly imagine. It's a place of breathtaking beauty and terrifying power, filled with mysteries that challenge the very limits of our understanding. The story of the cosmos is our story. It is the story of where everything came from, including the atoms that make up your body, the air you breathe, and the ground beneath your feet. To explore the universe is to embark on the greatest detective story of all time. We are cosmic detectives piecing together clues from starlight that has traveled for millions, even billions of years to reach us. Every photon of light is a messenger from a distant past, carrying secrets of cosmic events that unfolded long before humanity ever existed. What secrets are waiting for us out there? What cosmic truths are hidden in the darkness between the stars? These questions have driven us for centuries. They inspired our ancestors to map the constellations and tell stories about the heavens. Today, they drive our scientists to build colossal telescopes and send robotic explorers to distant worlds. The universe doesn't give up its secrets easily. It forces us to be clever, to be patient, and to be bold in our thinking. It challenges us to imagine concepts like infinite space, invisible matter, and time that can stretch and shrink. Are you ready to take a journey through space-time? Are you prepared to have your mind expanded by the sheer scale and strangeness of it all? Let's begin our journey. We will travel back to the dawn of time itself, witness the birth of galaxies, and explore the most violent and mysterious objects in creation. We will look for worlds like our own and ponder the question of whether we are alone. The universe is a book of infinite pages, and we have only just begun to read the first chapter. The facts we are about to uncover are more than just trivia. They are fundamental truths about the reality we inhabit. They connect us to the cosmos in the most intimate way possible, reminding us that we are not just living in the universe, we are the universe experiencing itself. So where did it all begin? How did this vast cosmos with its billions of galaxies spring into existence? Our best scientific understanding points to a moment, a single, infinitesimally small and unimaginably hot point. This wasn't an explosion in space because space itself did not yet exist. It was an explosion of space. All matter, all energy, all of space-time was contained in this singular point. We call this moment the Big Bang. About 13.8 billion years ago, for reasons we still don't fully understand, this point began to expand at an incredible rate, and the universe was born. Think of it like this. Imagine the entire universe, with all its future stars, galaxies, compressed into something smaller than a single atom. It was a place of perfect simplicity and unimaginable energy. Then in a fraction of a second it inflated. This period, called cosmic inflation, stretched the fabric of space-time faster than the speed of light. It was this rapid expansion that made the universe so vast and smoothed out its initial structure, setting the stage for everything that would follow. The universe went from subatomic in size to astronomically large in an instant. A truly mind-boggling concept. Isn't that an incredible origin story for everything we see? In the first few moments after the Big Bang, the universe was a scorching, dense soup of fundamental particles. It was too hot for even atoms to form, an opaque fog where light could not travel freely. For about 380,000 years, the universe continued to expand and cool. Finally, it cooled enough for protons and electrons to combine and form the first atoms, mostly hydrogen, helium. At this moment, the universe suddenly became transparent. Light was set free to travel across the cosmos for the first time, and this ancient light is something we can still detect today. This first light is called the cosmic microwave background radiation. It is the afterglow of the Big Bang, an echo of creation that fills all of space. When we point our radio telescopes to the sky, we can see this faint, uniform glow in every direction. It is the oldest picture of the universe we will ever have. A baby picture of the cosmos when it was just a few 100,000 years old. It carries the seeds of the great structures we see today. The tiny temperature fluctuations in this background radiation were the starting points where gravity would later pull matter together to form the first stars and galaxies. After the universe became transparent, the cosmos entered the cosmic dark ages. But it wasn't perfectly uniform. Gravity, the great cosmic architect, began pulling vast clouds of hydrogen and helium gas into denser regions. As these clouds collapsed, their cores grew incredibly hot until nuclear fusion ignited. A star was born, and the Dark Ages ended. The first stars were giants, hundreds of times more massive than our sun. They burned hot and bright but lived for only a few million years. Their explosive deaths as supernovae forged heavier elements and blasted them into space, enriching the cosmos. This enriched dust and gas provided the raw materials for new stars and galaxies. Over billions of years, gravity assembled this material into the vast cosmic web we see today. Around new stars, leftover material formed swirling protoplanetary disks, the birthplaces of planets. Within these disks, tiny grains of dust and ice stuck together, growing into larger bodies called planetesimals. Close to the star, where it was warmer, these formed small, rocky planets like Earth. Farther out, it was cold enough for ices to exist, allowing massive cores to form and sweep up gas, becoming gas giants like Jupiter. This isn't just a theory. With telescopes like Hubble and James Webb, we can peer into distant stellar nurseries and see these protoplanetary disks directly. We can even spot the gaps and rings carved out by newborn planets, confirming our understanding of how worlds are made. For centuries, we wondered if other stars had planets. Now we know, our galaxy is filled with them. We've entered a new era of discovery, finding that exoplanets are not just possible but incredibly common. We find most using the transit method. When a planet passes in front of its star, it causes a tiny periodic dip in the star's brightness. Telescopes like Kepler and TESS search for these telltale dips, revealing a stunning diversity of worlds, from hot Jupiters to small rocky planets that might be like Earth. The numbers are staggering. We now estimate there's at least one planet for every star in our galaxy. That means hundreds of billions of planets, some in the habitable zone, where conditions could be right for liquid water, a key ingredient for life. This leads to the ultimate question: are we alone? The James Webb Space Telescope is helping us find out, by analyzing exoplanet atmospheres for chemical biosignatures like oxygen and methane. Finding life beyond Earth would be the most profound discovery in human history. Our cosmic journey began with a bang, but how will it all end? The universe's fate depends on a cosmic tug-of-war. Gravity tries to pull everything together while dark energy pushes it all apart, causing the universe's expansion to accelerate. Right now, dark energy has the upper hand. If this continues, we're headed for the big freeze. The universe will expand forever. Galaxies will recede beyond our view, leaving our own isolated in a vast dark void. Over trillions of years, the stars will burn out. Only stellar remnants like black holes will remain, and even they may eventually evaporate. After trillions upon trillions of years, the universe could become a cold, dark, and empty void. A quiet, cold end to a fiery beginning.